Well, I'm not too thrilled about the possibility of doing a whole bunch of algebra to this equation to solve for the possible values of x. That will probably be a not fun process since none of the denominators are the same and so on. But I'm pretty pleased that the question isn't asking us to solve for all the values of x. It's just asking for one. It's just saying which of the following could be a value of x. So that means that, well, we don't need to know everything. We can just go to these answer choices and ask ourselves, well, could that work up here? Could that work up here? And I'd say that's a fairly reliable guideline. That when they use that word could in their question stem, well, working with the answer choices or back solving or whatever you want to call it is often a pretty good strategy. So let's just see if we can make some progress. Just checking whether these answer choices could be a value of x. So I don't know, what's the easiest one to work with first? Probably that's 0. Could x be 0? Well, if we plugged in 0 for x, what would happen? What would happen to this first term? If we had a 0 on the bottom, well, there's immediately a problem there, right? We're not allowed to divide by 0. Anything divided by 0 is undefined. It's nonsensical. So x cannot be 0. So a is gone. And let's see if we can use similar logic for these other fractions. What would make us divide by 0 in this second term? Well, the denominator is x plus 1. So if x were negative 1, well, then the denominator would be 0, and we can't have that. So x cannot be negative 1. So b is gone as well. And over here, we can't have x negative 4 because that would give us a 0 down here. So e is gone also. Down to 2 answer choices, which is a great place to be because we just need to test one. And either it's it, and x could be that, and we click it, or it doesn't work. It doesn't make a valid equation, and then we know the other, whatever one we didn't plug in will be our answer. So let's plug one of these in. Let's plug in, let's plug in negative 2, just because it looks easier. So let's plug in negative 2 for all our x's. That leads to 1 over negative 2 minus 1 over negative 2 plus 1 equals 1 over negative 2 plus 4. Simplifying. First term becomes negative a half. Second term, 1 over negative 2 plus 1 is negative 1. And 1 over negative 2 plus 4 is positive 2. And continuing, we get negative a half minus, well, this whole thing is just negative 1, right? 1 divided by negative 1 is negative 1. Equals a half. And negative a half minus negative 1. Minus negative 1, that's the same as saying negative a half plus 1 equals a half. And negative a half plus 1, well, that is a half. A half equals a half. And that is true. A half does equal a half. So negative 2 is a possible value of x, and we click C.